All right. Live, but not yet completely set up because it looks like my camera's messed up for some reason. Ah, it's because I have it. Yeah. Alright, we'll reset the anchor. I have no idea where that went, but yeah, it's that's fixed now. Mostly, kind of. Yeah, there's good. Actually, controller for a second and actually make it so I can see my screens. Throw that one right there. Throw this one right here. I wish they let you do curved screens that float in the world, because it's like curved in the actual dashboard. But then once you actually like make it float in the world so you can still see it once you close the Steam menu, then all of a sudden it yes, a volley avatar. Come on, hand tracking. Hand tracking. Hand tracking? There we go. Locking my controls there so I don't zoom around on accident. And there we go. Add a pop-up. Pop-up. Okay. There we go. Alright, let's get the dev environment set up. Like, I can't fully set up the stream environment before going live, or else I'll never go live. I just kind of have to, like, start streaming, and then, you know, then I'm streaming. Here, I'm gonna move the... Why won't it let me grab the oh, whatever. There we go. Move the camera so it's not 2 inches away from my face. There we go. Alright, and we'll just have that browser there in case we need it. And let me show you what I've gotten done off stream, because I actually have gotten, like, some stuff done off stream. Even though that's usually not always mostly the case. So once this is done loading, we can go in and... This is a very old workspace. This is taking a... Music. Good afternoon. How goes it? But... I guess we can just look at main for now. Why is this being so laggy? Maybe that's a Steam VR bug. It has like a little loading circle over my mouse, but I'm not seeing that on the screen. So... Hello Malik, how's it going? But yeah, so... basically off stream I got it so the majority of the parsing stuff is implemented now. So if I go and run this, or I wanted to put a breakpoint there because otherwise it immediately returns, but if I just run this here, I'll be able to show you like the grammar actually parsing. So right now, if my binds actually work, I can show you that this is the example script that we're currently parsing. So one module with a single pipeline with two pipeline stages. One of the pipelines with an implicit call signature and one with an explicit call signature. And here is the result of that. Right now I'm only printing out the like, oh, we found this module. We can print out that we found a little bit more things now, because all of this should be being parsed into document context nodes. This print statement here is mostly unchanged, because this is just going off of the tree sitter parse tree. So as long as my grammar is correct, this is also correct. Which I guess is another thing, is the grammar's all like fully working now. Like it might even be able to parse my entire like full test case at this point, though I haven't tested that. But yeah, so the next steps here are, I guess, 1, 2, and I just realized I've been meaning to record streams so that I can actually do streaming tabs. There we go. Hello, recording. We are actually recording now. But yeah, so all the grammar is now working. I'm not actually showing any of the results of parsing that, but if I go over to parser and then document context, I have all of these document context nodes, and each one of them, it's kind of like a representation of the grammar, but in a data structure that we can run more fancy operations on, like look up symbols and whatnot. This is what the first version of Brane script was using near the end. This is like the direction that the refactors were going. So it's a very easy way to not have to use the tree sitter API. It's more usable tree data structure. And where do we need to go next from here? We need to now transfer from this representation, which works really well for finding out information about the like structure of the scripts. We need to go from this to an intermediate representation. And the purpose of the intermediate representation is it describes the actual, like, most basic commands that the language can do. So this is your like, basically we need to create a version of, I think it's, might be WAT, W-A-T, is WebAssembly's text format. Yeah, which looks kind of like this. And there's also a binary version of this. Do you have a Brane script, Brane engine FAQ? Not at the moment. That'd probably be a good thing to add to, probably be a good thing to add over here. But I haven't done that. I guess the best FAQ is just like the Discord for now, though that's not very persistent. That's a good idea. I should do that. We will make a Brane FAQ. I'll say I'm gonna actually write that down. Where is my notepad? Alright, that's written down, so it will maybe happen at some point. Oh no. Looks like my YouTube stream is lagging. Not receiving enough video to maintain smooth streaming. Oh, is that because I have it on like super low latency on the YouTube side? Potentially. Can I change the stream latency at runtime? Twitch is lagging too? Oh, that's... That might be a parent's Wi-Fi situation. Oh. I'll try dropping the bit rate slightly. And see if that works at all. So that's like, might be slightly better. Oh yeah, I can see it glitching over there on Twitch too. Maybe somebody's downloading something big right now. Did nothing? Give it a couple seconds. What is the best suggestion for a VR headset that is cheap enough for someone broke that also won't be outdated in like 16 months? Probably the Quest 3S. That is like the cheap option. Why is my video like dying? Have I ever used OpenGL? Very briefly. Haven't gone too deep into it, but I got like a mesh rendering with it before. That was just the video output. I don't know. Here, let me check. Let's do the task manager check. I did switch over to, oh man. Task manager is definitely lagging out the entire PC though. Okay. That's my my GPU's at 100% for some reason. And I have the stream running on GPU encoding when I usually do CPU encoding. So, here, 1 second. Can I change the video encoder at runtime? I can. How did I learn OpenGL? I usually am a user of single tutorials. Here, 1 second. Let me make sure that the stream quality is holding potentially steadier. No, that still looks super laggy. What is going on? Here, let me try bypassing some network stuff by connecting. So I have like my own router I have hooked up to one of the family's like mesh network routers. So let me try connecting to Wi-Fi instead of the Ethernet cable, and potentially that makes stuff work a little bit better. Yeah, learnopengl.com is a really good one. Don't read everything on there. Just jump in, try to start building, and you'll learn a lot quicker by just doing. Hopefully DeepSeek isn't hogging up your GPU. I'm not running it right now, though. I mean, I can fully quit Olama. I think it's just running in the background. Where'd Task Manager go? Did I close Task Manager? Okay. Come on, that like nuked the start of the stream. I just want it to work. Just I did update OBS. I wonder if it's the new OBS version messing with stuff. Do I need to update graphics drivers as well or something? Looking to the encoder preset, since it wasn't the video bitrate, I'm gonna up that a little bit. And dang. I'm gonna try like stopping streaming and then restarting streaming. Was it when I started recording? Okay. So stream. Okay, so stream restarted. Refresh if no stream. And that looks smooth. It might have been... Yeah. It might have been that I started recording with, like, a GPU encoder. So if I look at, like, Task Manager, now I'm at only 83% on the GPU as opposed to the straight 100% that it was before. Okay. I'm also gonna drop, like, my frame rate on Steam VR. Because that'll just, like, make stuff look visually better. All that on manual. Okay. Alright. Hello. Eleconic? How do I pronounce your name? Econic? I think it was Econic. Yes. Hello. Yeah, getting back to what I was saying before, something on my computer screwed up. We are going to work on the intermediate representation, or generating the intermediate representation for the language, which is basically the both serializable and runtime loadable version of the language that condenses everything down to the smallest form that it can be. Indeed, VR chat over socialization. Or not VR chat. Or my thing is coding over socialization. You got me there. Isn't VR chat socialization though? Like, it counts. It counts. But yeah, so now hardest part of this is deciding how we want physical socializing. You don't need to physically socialize. We don't need async operations anymore. Those don't exist. And okay. What was I going for before? So we have move operations, load operations, store operations, add operations. Of your regular mathematical operations, equality operations. So these are all your, like, low-level stuff that you want to do. Do I have a call operation? Doesn't look like I have a call operation. As someone who has been outside, physical socialization is overrated. That's what I'm saying. Like, I too have physically socialized, and like, eh? So the main, like, thing that I currently haven't decided for how the actual operations are going to work is, technically, I could represent every single one of these operations as just a function call. Like, I could use the same function call syntax for just everything. And it would work. Like, it would work fine. And then, like, it's now on the burden of the actual runtime to determine what's actual... Which one of these are actual assembly language commands, where, like, we just put in a little bit of native JIT stuff in here, or is it an actual call to a function in the runtime and let the... this would be greater equal. So, equal, not equal, greater than, and greater equal. And then I don't have less than, because to do less than, you just swap the operands. And then I expect the smallest amount of optimization to swap them if it makes sense. That's the do-gooder from Ready Player One? Who's the do-gooder in Ready Player One? I don't remember this character. I'm not getting any results. Oh well. Why not just type them out? Because I like being like, oh, I know assembly language, and these are what they're called in assembly language. Ha ha ha. So it is kind of just that they represent assembly language things. So yeah, so this is if I wanted to serialize this out to a bitcode, which is what I did with the previous versions of Brane script. So go here, and we look at the first version of the language. Go to, would it be in script runtime? It would be, where would it be in? Maybe native types? Somewhere in here I had a giant enum of every single... actually no. With this particular version of the language, I might have just been using LLVM intermediate representation. Like the robot avatar in holiday journals? Okay. Yeah, I guess I was just sending LLVM modules over the network, and... well, not even over the network, because there wasn't a network to send them over in this version of the language. I just compiled directly to LLVM. Which isn't ideal. They had the document context stuff. And then what did the constant expression evaluator do? I mean, I know what it did. It evaluated constant expressions, but what data structures was it operating on? Age demographic of the books? The books were definitely like a higher age bracket than the movie, that's for sure. But still childish in a way, if that makes sense. Very gamer, I would say. Very, very, very gamer. So I did use these context nodes. Okay, so this is going over document context and then doing constant simplifying document context, which isn't what I want to do. I want the document context to purely be context about the document and not the actual representation of operations. Definitely want a translation step there. So I guess it would be a lot further back in the history of this language that would be the bytecode version of it. Whenever I added LLVM instead of AwesomeJit, which is what I was using before. Like, I had so much stuff working on here, but my foundations were terrible. So I think it was on the previous page here. And this will be probably a decent one to look at. So if I look at files at this point in history, who needs foundations anyway? If you want to build a very tall building, which is kind of what I want to do, then you need some foundations. So we still have the IR script class, but where was the actual intermediate representation? Maybe it was in script runtime. Streaming, what is it? Okay. So yeah, I made all these nodes. So if we look at the AOT nodes, these will be what generates the actual generate bytecode, and then wait, did I just do I might not have had a bitcode here either. No, I did. Where's that enum coming from? Dang it, where's the enum coming from? I just want to show off the enum. AOT operation nodes age. AOT nodes. Oh, well, that's the node type. I'm solving this problem by using standard variants. And then, not value index. Oh, wait, no, there it is, operands. Here it is. So basically, this in a much earlier version of this, 3 years ago. This was how I actually serialized the language. So there's literally a bit code, so these are all the operands I had. And then those got compiled to... yeah. I wanted to ask if you use some AI to help decode. On occasion, I try not to rely on it as much as possible. But then if I'm like really stumped on something, then I will attempt to use it for that. I also use it for like concepting sometimes, or very loose, like describe a general pattern and then it gives me the actual name for that thing, because generally I'm bad at like I'm good at remembering concepts but bad at remembering their names. So if I describe a concept, a lot of times it's able to like here's the like real terminology for that, and then I'm able to actually do Google searches with that. Yeah. So I get the thing that I'm trying to decide right now is I could go all in on just emitting a representation of this that is essentially assembly code. Like, that's one thing I could do. Then I would have to deal with registers and all of that. The other thing I could do is go for more of like a text-based WASM approach, where you still have kind of an assembly language approach, but they do this as a stack machine, which means you don't really pass... I mean, I guess they do have occasional arguments to things, but you don't pass arguments to functions. Instead, what you do is... instead of passing arguments to functions, when you do call, it just uses it pops values off of the stack. And any operation that consumes values just pops pushed values off of the stack. So that's one direction we could go. Though, I am not a fan of just having stuff be a stack machine, even though I know it could get optimized out. I don't like the idea of they're actually having to, like, relying on optimization passes to make it be optimized. Even if they are, I guess, potentially somewhat simple optimization passes. I don't actually know the cost of those optimization passes. So what I want to do is I want to serialize the intermediate representation of Brane script as a tree of operations. Kind of like a, I can't remember the exact term of it, but like a diegetic syntax graph. What is LLVM IR? Let's see, what graph type does LLVM use? CFG. No, wait. Single assignment. I think it's a single assignment graph. Single assignment graph? No. No, that's not what it's called. What's the name of the, Don't come in, Mom, I'm streaming. That's my brother. But, like, I was moved out for a bit, and then I had to move back in. Even though I'm not in my teens anymore. I was doing this in my teens. But come on, what was the what? I might need to like chat GPT this, to be honest. What? What's that? What graph type is common in compilers for optimization and representing operations? Maybe it is the control flow graph. No, it's the data flow graph that I'm thinking. No. This is what I'm looking for. Static single assignment form. Which means that every time you create a value, it can never be assigned to again. Very like functional programming-esque. So like I don't want the intermediate representation of my language to have to deal directly with registers. I'm just not interested in writing a register allocator, because that's something I struggled with a lot in the past. Is I don't want to write a register allocator, but I do want to use register-esque syntax in the intermediate representation. So this is a good in-between, where static single assignment form, where every time we create a new value, it gets assigned a new like value index, I guess. But then again, it doesn't need to be static single assignment, technically. Yeah, I don't know. Yeah, static single assignment actually doesn't make sense for serialization, because you want it to be as, I guess, small as possible, which means if you're using unique if you're using unique identifiers for every type, that's even going to mess up stuff like compression, because it won't be able to combine those. I guess we'll just pull out a notepad. I have it right here because I use it so often. So I do want it to be tree-based instead of just like operations. So where I guess still very loosely tree-based, because it would be like, here's a scope, and then the scope has a ton of children, which is like operation. Actually, no. Single assignment form would still work for that. I guess leaf nodes would be, okay, let's say you have like an operation A and an operation B, and then you have an operation C which relies on operation A and B. A and B would be then children of C in this node graph. But what if you have an operation D that also requires the results of A, say B, like C and B, just to keep it interesting. Now suddenly B is a child of both of these graphs. Or yeah, so we have like value A, value B, and these are like constants or something. We have a value C, which requires the result of these two, which makes this tree structure. Then we have D, that may require these two, which makes something like a JSON like representation of this, where that is the structure, doesn't make a lot of sense at all. Because you have like this diamond problem, I guess is maybe what it's called. Or I guess we'd be like redefining B or getting references to it. You're on a Windows machine, not using OneNote? I'm not a Windows lover, so I try to avoid using Windows first-party products. Fair bit. Even though, like, here we are in Paint with Notepad. I don't like being stuck on Windows, I guess is the thing I like to say. Don't use the stack, you shove everything on the heap like Java? No. Even though technically that is kind of what I'm doing, because runtime, like... I guess the persistent values that cross pipeline stage boundaries do have to be stored on the heap. But inside the functions, I want to use the stack as much as possible, which is still kind of what Java does. Well, no, the problem I'm running into here isn't that things are being assigned to the same ID. It's that multiple things rely on the same ID, so I can't do like my cool graph structure that I wanted to do. The problem is well, let's say that I have a loop as well, and then like at the end of the loop, we're setting like x is equal to x plus 1. How do you like single assignment a form represent that? You use something called a lambda statement, and that's not something I want to exist in my intermediate representation. That's too complicated. So I'm so drifting back towards this syntax here, and I guess I'll just do like an index of values. That makes sense. Well, one thing that I do need to take into account is that when you have control flow in WASM, oh, come on, give me an example. Yeah, when you have control flow in WASM, there is actually scoping inherent to their like intermediate lowest level. So when there is a loop, everything inside the loop is like there's no jump instructions. Like there's no go-to statement, which is something that I want in Brane script. Like I don't want there to be a go-to instruction in the actual intermediate representation, because say somebody writes a custom compiler and is trying to do like weird malicious things and crash the runtime. Like this makes it a lot harder to make like infinitely recursive control flow stuff, because I know that there's a loop here. it's in the thing. So if I ever need to do something extreme, like have the runtime automatically break out of loops if they like go too long, I can do that. Interesting, they have blocks. Break increment loop, break if increment loop break. Are these comments? No, that's not a comment. Might be a job for switch cases? Maybe. That's how I've implemented it in the past. With these just as a giant enum instead of a variant. I like the variant because that means that they can store info. They can store data. Well, let's just get... I can figure out control flow after getting something working. So I guess the main question I have is, how do I want to serialize? Because I want to do a human-readable, like, a human-readable representation of Brane script, intermediate representation. I also want to do a binary serialized version of it. That's pretty standard in every single compiler system, is there's a version of the IR that you can read, and there's a version of the IR that the computer likes. So like LVM, IR, which looks like this. So this is what your compiler sees. That's like the one step above assembly language, like barely a step above assembly language. It basically is assembly language, but with like control flow stuff built in, so it can be optimized. So what does my version of this look like? I don't want it to be as freeform as LLVM. I am tempted to just directly rip off Wasm as I am doing in every other situation. Kind of rip it off. Not fully rip it off, but kind of rip it off. We already are at reinventing the wheel. It's too late for that. We're making a coding language. At this point, like, how much of the wheel do we reinvent? Is it's not super huge fan of like the parentheses notation. Very easy to write, though. More wheels you reinvent, the more it will never ship. It's going to ship. I'm gonna... Okay. You know what? Screw it. I actually am gonna try it. Jack, I'm actually gonna try to have this done by AWE now. It's gonna ship. Ships only have one wheel usually. I mean... Kind of. Kind of. Or at least some MVP. I don't think I can have multiplayer done by AWE. Because I've actually written a multiplayer system for last AWE before, and that took a month. And that was building a multiplayer system for Unity, where I had already written the Unity serialization side before, in the past. So, I don't think I can get multiplayer working before AWE, but I do think I can get like an in-headset demo, where you have a client on the headset, or at least a client running on a PC and then the headset connected to the PC. I would love to have a Android native build working by then. Like, that would be amazing. That would... I don't trust the Android build chain enough, though, to, like, promise that. Or, honestly, I shouldn't promise anything. Submitted a random talk where I'm like, I don't know, just put me with some people. like a panel? There's a relatively third-party C# solution for multiplayer. Not sure how hard you want to lean into not my code so I don't know it territory. So I don't want C# touching any of this at the moment. Like, I wrote my multiplayer backend for a C# system in Rust. So in a month I wrote an entire Rust networking solution. That never crashed once. It was very effective. I was able to walk around the convention floor while there was a live demo running with my code. And it wasn't the Rust code that I had written that ever crashed. It was always Unity side, which I'm not sure where it was crashing, because it was like super weird. That might have just been like memory. They had like really big worlds, so I'm like half convinced it was like too much VRAM usage or something. What do you mean the Android build chain is Java? I think that means it never breaks. You never built a Unity app to a Quest then. It breaks very often. It breaks more often than you can actually build. Maybe that's a Unity issue, though. Okay, so... It is always a Unity issue. Yeah. Okay, so... You know what? Fine. We'll rip off some more of the WASM's system, specifically how they represent intermediate representation. Because I was originally going to go, I will use JSON as the human readable intermediate representation, which is not like compact enough. By far, probably. Instead, what we should do is... I want to make the syntax a little bit more readable than this, though. So let's say, what do we need to represent in a Brane script file? The XR interaction toolkit. And the XR interaction toolkit is interesting. But yeah, we will see if people like my interaction system that I end up building more. We will see. I don't really have a ton of, like... It will be a journey. I'll say that. Okay. So in Brane script, intermediate representation, we have a couple different questions I need to ask myself. Do I want to define dependencies inside of Brane script itself? Like, obviously we should define modules, define inside of modules, define pipelines and functions. But here's the thing, should I define see, I have it so that modules we do need to define what modules link to, because in how I imagine Brane script working is that every single module is its own. Here, I can turn off the debug adapter here. I wanted it on the other page. There we go. You can see we have this module test. If we had another mod, test 2, I very much want Brane script to be also like very able to be very modularly loaded into everything. Like, I want to avoid having like really big compile targets that take forever to compile, and like mostly rely on the linker for linking them together, or like whatever linker runtime I put in here. That does like slightly limit the amount of inlining optimizations you can do at runtime when you're actually loading it. But I think the benefit of being able to not have a script in the scene that you don't need, it outweighs that other. Why exactly did you do stuff like? Because this is Rust syntax. It's literally because it's a Rust syntax, and I'm blatantly ripping off Rust for the syntax of the language, and I want to keep it cohesive in its ripping offness. Like, I can add some syntax here, like how pipelines work, but I'm trying to keep the rest of stuff more more cohesive in that. Sorry, I'm going full Rustation on how the scripting language actually works. It will be more readable than Rust because we're not doing lifetimes. But I do like the aspect that Rust has where nothing is implicit. Aside from like some value type, I guess derivement, the thing where it automatically finds automatically, like the let type is automatically figuring out the return type of stuff. Mostly because types get super huge with all the template generics and stuff. Okay, so I think if module test needs functions from module test 2, then I think we define module links, but not where to source them from. I think this is the job of the runtime to decide this. So when I implement this into Brane Engine, the script assets will contain Brane Engine modules, and then the Brane Engine script assets will then define how to find other Brane Engine script assets and like the dependencies of that and everything. Just give us an option to use static types instead of let. There is. You just say let value and then semicolon and then the type. There you go. Sorry, but I'm sticking with the syntax. Oh, this is a small amount of code. What do you mean? Look at all that code. And this is the small project. This isn't Brane Engine. Do I have the bragging stats pie file in here? I don't, so I can't actually check line count. Okay, so we will define... Well, I guess if we are ripping off Wasm for Wasm imports... So, imports, I spent a lot of time on this. Okay, so yeah, this importing and exporting stuff is what I was wondering they were doing. So import from provider, add. Okay, I guess the module gets its name from the module instead of naming itself. I mean, the abbreviation for the language is BS, so take that as you will. Now, do I need to define the actual... Define imported symbols, and the symbol itself will have the name as part of the thing. Then if we define... Here we define our pipelines and functions / types. And potentially even persistent data, though I'm not dealing with globals. How does it do exports? So it just says export this as add. It's not going to be. It's not going to be in any of ChatGPT's training data. But, like, you won't have to deal with any of the stuff that I'm writing right now. This is all, like, stuff the language handles for you. You will have to deal with this, but it's probably going to look similar enough to Rust that it will be able to figure it out. Okay, so what types do we need? We don't necessarily... I don't want this to be a D operation. We want this to be IR operation. There we go. It's similar to Rust. Why not just use it? Because Rust doesn't compile to... I can't make a custom runtime for Rust. And the custom runtime is the most important part of this. Now I'll write actual documentation and then you can just train it on that. Be an IR module. And these don't need to be pointers. I think. Maybe I might want to do the node system. So I do want to pass references to these around, so we'll stick with shared pointer for now. So struct functions and pipelines. Do I want to define pipeline stages as functions? They probably are scoped to structs. Not destructs. Yeah. We don't need async operations anymore. Okay, so this does have parameters and results. Interesting how these have parentheses around, don't have parentheses around them. But in here, they do have parentheses around every single operation. I wonder if that's an optional thing. I could, but I actually don't care. The main thing I'm trying to decide is if I would want to make it optional, my syntax, and I don't think I do. Yeah, I do think that I define pipeline stages as functions, and then scope functions to the namespace of the pipeline. I don't think I let people do scoped modules. Do I let people do scope modules? I don't know. I guess I just have to come up with a syntax for scoped identifiers and keep that consistent. And I think when I actually parse this out, like the human readable version of this will have the symbols in line, but the binary version will just define all the symbols up front, and then any time in here that we would use a like identifier, anytime that we would use an identifier, then it just links back to this. But then again, that's for the actual serialization portion, whereas this is the computer representation of it. So let's... Alright, plan of attack. We'll finish out writing out this version of it, like the computer representation of this. I32 is normal int, but it's just more explicit about the size of the integer, which is actually something that I'm very annoyed at for like regular integers, is they don't explicitly say what size they are in the name. So I am very much a fan of like the I32 and U32 and F32 and all that sort of stuff. It is open source though, so if you want to make your own like parser and then do a pull request with a way to switch out the parser to use different names for different types, and then suddenly your code like projects are like, as long as it compiles out the same, it's fine. So if you want that bad enough, pull request. I mean, it doesn't replace the whole structure. All you'd have to do is go into Grammar.js here. And I mean, if you want to use types first instead of doing it with like the semicolon, you would just go here and instead of let, you do just value def, and then you would rewrite value def wherever it is. Then you'd rewrite value def to put this thing over here in the front, no semicolon, and then you would just have the identifier there. And that rewrites that basically everywhere. And then for the type stuff, the actual names of types isn't even in the grammar. You just go to wherever I parse out what types are what, or even create an alias. What do you need to compile something for it to work in Brane engine? You need the right now I'm just working on a CLI command line application for the actual testing of the parser. Eventually the CLI, like some portion of it, will be embedded into the like editor, and then the editor will manage calling to a library, not a CLI program, but like just statically linked this whole toolchain I'm working on now. And then that will compile out to this intermediate representation I'm working on now, hopefully the binary version of it. But then this binary representation is what actually loads into the runtime. So technically, you can write a compiler to compile normal-looking languages into the IIR and it will work. Yes. And I could even write I could even write some sort of interface, Brane engine side to support that, and that is something that I would be open to doing. Um, I just like the idea of, especially for like the pipeline stuff, having a syntax where I can make stuff easier instead of being like reliant on the grammar of an existing language. But yes, I could provide an interface to let people write their own parsers, and potentially even like full compilers. As long as it compiles down to this, which is what we are currently defining. Allows them to reinvent your reinvention of the wheel. Yep. Good luck. Does BF support any form of asynchronicity? Because if it doesn't, you're gonna have to figure out some way to manage that. Or multiple functions. Does it even define? Okay, so there are extensions of the language to allow you to write out things like functions. So the default like BF is just interpreted um, as one function. So it would take a good bit of work to get it to the point where it would be able to compile to something like this. Oh, I don't want... I mean, they probably are just joking, but spent like months actually getting it compiling. So it's a possibility. Okay, but locking in here, I think I finally have an idea of where I want to go with this. And I just want to decide, okay, how does BS type work? So I have BS base type, transcript base type, which is this, like native type. We're gonna rename this to native type because that makes more sense. Then we also have struct types. For now has iron node, which I think iron node is just a shared pointer. Yeah. Also have reference types. Do I need to define mutability? I guess for the purposes of linking functions, yes, I do need to do mutability. No, well, do I? I guess when linking it might be important. At least it's not Python. At least it won't be Python. I wish I could do one of my 200 BPM speed core mixes, but I don't know if how copyright strikeable those are. This has some sort of brackets. It has many brackets. It has all of the brackets. It is overly verbose rather than not verbose enough. Okay, back to locking in. This is fine, I think. Currently, struct types aren't implemented. For this to work, I do need to implement struct types, at least for some argument types, because technically this is an anonymous struct. It's not going to trip up the compiler if you want to use a different bracket style. You mean like on like which line it's on? The compiler doesn't see new lines or spaces. And technically it's not the compiler, it's the parser and lexer that you need to be worried about. I mean, it does see new lines in the case of comments, but that's beside the point. It can selectively choose when to see them and when not, too. This needs a... Those are 4 flow of worms? Those are threads, flows of data. That's kind of the lore behind this. This is like Brane, but manifested. Type. How am I going to implement anonymous structs? Because we need the IDs to not clash. Or actually, no, I do want the IDs to clash. Because I want to be able to combine the types compiler side. At least in like struct definitions and whatnot. Struct IDs don't really matter. I almost want... I almost want to reduce structs down to only the types they contain. So then that would be a struct type is literally just... I mean, of course we have to add debug info to this later. And that debug info would contain its name, optionally. Which is something that we can do, we can add in debug info here. Like, as soon as I get one thing compiling, the next step is we get the debugger working with it as well. Like, I can get GDB and LLDB working with this. So that's what we do next, but... we need to put this underneath here, and we need to say struct. BS struct type, predefine it there. Then we have a vector of Brane script type. I'll just call this members. And at some point I'll put debug info there, and we'll break this out into I'm going to put this inside a struct just so that later I can add debug info there and not have to fully refactor everything. And then we have IR values, which is just a uint32 at the moment, which I don't think we're going to exceed the max value of 32-bit ints inside of a single function for like new values created, probably, hopefully. Could make a 64-bit just in case, but I don't think it should be a problem. And these are going to be all over the place, so this would dramatically increase or decrease the size of the size of compiled objects, changing that value. Doubles it, or undoubles it, like, because this is the main like argument to most operations or operators. Becomes a problem, I'll make there be a flag to enable like changing the size of that. So now we have IR operations. Now, what I need to decide is let's see how control flow works in WASM. Break table. So it does have a switch statement system. And you can also say which block to break out of, because apparently you can label those. But loops are different than a block. The basic blocks are very... This is how you do if statements in LLVM, is with basic blocks. Basically all control flow in LLVM is you have basic blocks and then you do like jumps between basic blocks. In fact, a basic block is... This goes against basic blocks, actually, in compilers. The idea of a basic block in a compiler is there is no branching inside of a basic block. They are the units of that you do control flow with, because in between basic blocks is when you do the branching. So this is like fundamentally not a compiler basic block. Kind of. Here's their equivalent of a while loop, is they just have a loop. And I wonder how they protect from infinite loops. How long would it take for a computer to count up to an int max value? Because I'm wondering if I just like... When I'm compiling out a loop, how do I make sure it's not an infinite loop and it doesn't kill that thread? Because I'm fine with putting a generic loop construct in. I'm just wondering what the largest value... If I put like a hard like if statement at the beginning of a loop, it's like, if loop exceeds X number of iterations, exit out of this script and throw some... like, report an error somewhere that the developer will see it. And be like, we didn't complete your... we didn't complete your job because it took far too long. Or far too many iterations. Please break it up with the asynchronous system. Yeah, see, if statements are a part of their grammar itself. Interesting. Switch statements are just implemented, like, verbatim. I do like having switch statements as part of the grammar. That is something that I would like to do. I'm not necessarily a fan of this, like, we're going to these blocks, and then here are the blocks. I wonder what a giant if-else block would look like this. Just very deeply nested if statements there. I don't think I'm going to do blocks. I may eventually see why I do want to do blocks. Like, I may have a reason to actually implement them. But if I just copy this if syntax, make this be a break table, but you put the blocks directly nested in here, in the same way that the if does a then else statement. So the blocks are just directly nested into this command. The only major headaches so far is me being indecisive about how I want this intermediate representation to actually look. Because once I decide what I actually want it to look like, development is going to go super fast. It's just the me trying to like design this at the same time as I'm coding it. And currently what this is over here is we're blatantly ripping off how Wasm stores their like WAP format. WebAssembly text format, WAT. Except I'm going to make it slightly more readable. Maybe, possibly. Well, yeah, the main thing I hadn't decided on here was branching. The other thing I need to potentially define is the actual values themselves. Because with specifically one of LLVM's optimizations, which is stack to register, like coding LLVM runtimes is a lot easier when you just treat every value like it's on the stack, and then let LLVM run an optimization pass to upgrade them to registers. So, but to do that, you need to put all of your variable definitions at the beginning of the function. Well, this is also completely like open source standard, so like I'm allowed by the license to steal it. I mean, it isn't technically stealing because it's legal, but English language. Indeed. Yeah, no, WebAssembly is For virtual machines, designed as a portable compilation target for programming language, blah 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 blah. Somewhere in here should be the actual repo. We go to the WebAssembly specification. You can see this is like part of a GitHub website. Somewhere in here, do they have a license on the actual spec? Yeah. Doesn't matter. Okay, but I am ripping their control flow system, aside from blocks, because I don't want blocks to be implemented. I don't have to deal with blocks, except when I'm coding LLVM, in which case I can abstract away the blocks. But I don't want them to exist. Because we'll never have to do a goto statement. I don't want there to be goto statements. There might be asynchronous equivalents of goto statements that can only move forward because screw goto statements. Okay, so these are... yeah. I'll need to define what these do. More concretely, because at the moment they're not type specific, which is not perfect. And they do need to be type specific. Oh, I do have a local variables in here already that has the IR types of each one of the local variables. Perfect. I don't need to add anything else to that. We'll call this ID as well to be in line with all of these. Do I need the structure? Well, I might want to look up structures by name. So maybe... how do I unify this structure with this? or not with that, with this. So we have this IR struct type, and then we have IR struct. I think we just do and that unifies it. And then we also need this to be an option. If my bindings will actually work. Okay. Actually, this should be a public include from the parser. Okay. Then if I restart the LSP, still doesn't find it. And this is next to... Oh. I was in the wrong area. I didn't want to run it, but... wanted to build the debug scripts. And now... it does find the options H header. I guess export details are only really needed... ID is only really needed if you're exporting it. The module is always exported. Because that's the name we export it under. Functions. Because you can have anonymous functions. I mean, that's kind of what a lot of pipeline stages are going to be, is just each one is going to be an anonymous function, unless it's explicitly named, which is something you can do. But at the end of the day, most of them are going to be anonymous functions without a name. Now the question is, do I name them secretly behind the scenes? Because if so, I need to come up with a generic naming solution for different types. That's something I'll figure out as we go. When I'm actually writing the parser, not the parser, the actual compilation stage, or the runtime loading stage. And that's when we actually need to name it. We don't need to name it though. LLVM, we can keep it unnamed. Wondering how we do lookup for anonymous structs. I guess it would just be like, I would create a utility function in my assembler. It's assembling the intermediate representation, and I would just do, or like my IR builder, or whatever I call this class. And I could do a get anonymous, or like create anonymous, like get anonymous structure. And that will either create a new structure type, or return to me one that already exists with the types that I need. Because I want anonymous structures with the same types to be, like, interchangeable, basically. Never want to get an error in the compiler. It's like, oh, I was expecting this type, but got this type, and it's two anonymous structs with the same member types. Like, those are the same structs. And admit, got zero code experience, so most of what you say is Greek to me. But I'm looking at starting with VC package and CMake. Should I set up a Windows image to code on, or is my Bazite install? What is a Bazite install? Good to go. You could do a Windows image, or you could do Linux, because you will also be able to code the engine on Linux. Like, it will be Linux native build. Bazel is Fedora-based clone of SteamOS? Okay, yeah. So Bazel will be good to go. Theoretically, you might have like some issues with a lot of times headers compile in a different order on different compilers, so you might have to throw some like utility and type headers into some files if it's like complaining about types not being found. But aside from that, it should be mostly ready to go already. I haven't tested Windows builds, I mean Linux builds, in a hot minute though, and the CI is definitely failing right now because I have screwed up tests in so many ways and not written more tests. No. I said screw it, we're not adding go-tos. Right now I'm still like fumbling around with these. The current thing I was thinking about is how do I want to do type-specific add like operations? Months of YouTube learning away from those being huge issues. No, there are immediate issues if you do clone the repo. But I mean, if you're saying like you're gonna try out the tech and start getting started with them, then no, they aren't immediate issues. Just get started with like a simple CMake project, VC package JSON, and then you're good to go. VC package doesn't take a lot to learn though. It's literally like you say install the thing, and then you use find package, and you find the package, and then it's really easy. Okay. Now, the thing I'm trying to decide right now is in WASM, you have the type and then the operation you're doing on the type. Like this is the WASM opcode table. This is one of my favorite web pages because it's so cool. Here's every single operation you can do in WASM, and the syntax for it is type dot and then the operation, and then it's a stack machine, so it just pops whatever arguments it needs off the stack, so you don't necessarily need to worry about arguments. It just happens. Like for instance, this will pop the 32-bit integer off the stack and then push a 64-bit float to the stack, which I guess would be two 32-bit integers. F32 demote F. Why you gotta do him like that? Demote. It's not convert, it's demote. What's the difference between demote and convert? That's actually a good question. F60. Come on. I remember where numbers are on my keyboard. Between converting and demoting. Explicitly reduces the precision. Behavior. The motion is specific to... Okay, so that's the general term. But what's the difference? Self-aware define narrowing of precision, whereas a conversion, they have different operands. So what's the difference? Reduces precision. Precision loss, yes. F32. There is an F32 demote. Is there an F64 convert? convert an unsigned 32-bit. So there's promote, which you call from here to promote a 32-bit float, and there's demote, but they also have convert, and also promote. Wait a second, are the conversions for integer types? The conversions are for integer types, okay. So they just use demote and promote as their naming for conversions for float types, and then convert is the type for... Do they hold that true for float? Non-float types? Like if I go to... Well, they just use reinterpret, so they like changing naming conventions all over the place. Okay. So let's look at our IR operations here. None of them are type specific. We do need to type specific them. Technically, I don't know. Values are type specific. The values are already... Like, when we define a function, we define every single variable that will ever exist inside the scope of the function. Even child scopes. We also need to do this for... No, we don't need to do this for this, because the output stages will define the types that they output. And those will be our transitionatory types. So do I want to make this type specific, or do I want to infer or derive the type to do this operation on by the values? Because if I want to do type conversions based on the implicit types of the values, then I could literally just do convert op, and then just do IR value from IR value 2. That's just a move operation. And the other thing is, do I want constants to be operations? LLMs are fun to play with. can be therapeutic or angering. I don't think I want constants. So the reason why constants are an actual operation in WASM is because it's a stack machine. So when you want to access a content, you push that constant onto the stack. We're not doing that here. So instead, we would need to have constant values be actually here. We actually need to define where we're setting this constant. And then it works. Yep. There. WebAssembly has a garbage collection proposal. Yup. SIMD and threads I can get behind. But yeah, they want garbage collection to be they want to put garbage collection directly into the WebAssembly language. Which I'm like, There's another thing like the components. I do want to look into SIMD, because I do want to very much like 90% of ECS optimizations is SIMD stuff. So at some point I do need to make BraneScript support SIMD on this intermediate representation level. Not today though. That is a future edition thing. So as long as we have the destination for all of these commands, it says source, which is our pointer. Lack of garbage collection cited as what holds WASM back a lot? How though? Like, is it just developers who have no clue how to code in non-garbage collected languages? Or is it that, like, they want to compile garbage collected languages to WASM, and they don't want to embed the entire runtime of the language into WASM, because that's what you need to do for garbage collected languages. In any case, like, keep garbage collected out of the like explicitly not garbage collected because it's fast system. I don't know. It's a missing basic feature. No, garbage collection is a large abstraction. I mean, even BraneScript is going to have a form of garbage collection. I think it's going to be closer to arena allocation. But for the most part, it's going to be like, here, everything is on the stack as much as possible. But like, with much more defined, I guess, barriers between where memory is actually handled. Hopefully we won't have memory... I mean, I'm planning ways to make it so we don't have garbage collection stutters. because I'm not going to build a garbage collector. Then we have a unary operator, which has our input and our output. That's all done correctly already. And then we'll have an assembler. When we're like loading the runtime stuff, I'll just throw an error if any of the types of these don't match. But eventually in here, I'm going to need to do a large load and large store operator as well for working with large sections of memory. Because I actually finally discovered how I was going to handle runtime's bounds checking of memory, which is one thing that I guess even WASM runtimes haven't really figured out, is like if you want more than 4 gigs of memory, and potentially you want smaller allocations than 4 gigs of memory to like not be shared between scripts, that's actually like rather hard to do, because you can try to doing like stuff with guard pages and whatnot to make sure one script isn't accessing the memory of another script. But the way that the WASM multi-memory proposal supports being able to link multiple sections of memory, I'm realizing I'm not making any sense right now because I am leaving out crucial bits of information. So the way that WASM works is that every single memory access operation, so let's say this is a store of memory. Every single WASM operation is relative to having a pointer to a store of memory. Like every single operation. Like if you do a pointer operation in WASM, behind the scenes, it's implicitly relative to this pointer. This means that WASM is inherently much safer than just like letting a runtime loaded piece of code just have raw access to pointers, because then suddenly you get into problems with like it accessing host memory, which is something you very much don't want it to do. And then like when I was trying to get WASM working as a scripting runtime, I wanted to use the 64-bit memory proposal, which adds in 64-bit pointers into WASM. Now, the way that to give a little bit more context, now we have like, oh, all memory is relative to this pointer here. So now we know that all of this pointer here within the max size of a 32-bit int is accessible to the program. Now we could do runtime bounds checking to make sure it doesn't go over a predefined limit, but that now means that on every single memory access operation, you need to do a runtime's bound check. There's an if statement on every single potential branching on every single memory access operation, which isn't ideal for your performance. Now, the way that stuff like WASM time gets around runtime memory checking all of this is you can just allocate 4 gigabytes of memory. You just allocate 4 gigabytes of memory. And now, because of the max size of a 32-bit integer, max uint32 is this much, and then you say bytes to gigabytes. Yeah, that's now half of your 8 gigabytes of RAM if you're running minimum specs. on your computer. However, you now know it can only access this memory. So now it's not able to access host memory because you know exactly where all of the memory that's being accessed is. Because of course it can't go here because that's like negative values. It's an unsigned integer. It can only go forward. Problem is, I don't want to just allocate 4 bytes of memory. And then the thing is, this only sandboxes scripts that use this store from the rest of the program. It doesn't sandbox between scripts. Because if you load multiple scripts into the same sandbox, you now know that, like, okay, you might say, hey, pretty please only use this memory and this memory. They can still technically access, if you're not doing runtime's balance checking, which is what we're trying to avoid, they can still technically access this memory, or you run it unperformantly. Like that, you can't do both. You can't run it performantly and also have runtime and also have it be secure. So my grand idea is, what if instead of pointers being a uint32, what if I made them a uint16? Which is a significantly smaller memory space. And this is also already the size that I allocate for entity component system pages. Because instead of being 4 gigabytes of your RAM, this is now 0.006% of a gigabyte. Meaning you can allocate and we'll just copy this in here. And let's say 1 divided by this many. Now I can allocate 15,000 and a little bit more pages of sandboxed memory if I constrain pointers to uint16s. Now, this does mean that the stack of every single function will be limited to that size. But I don't think that's like 65,000 bytes. I don't think that's a problem for the stack, specifically because by the nature of Brane script and its asynchronous nature, we're constantly jumping between functions. Like each pipeline stage is its own function with its own separate stack, which means ideally we're keeping these pipeline stages small and like just quickly clearing our stack frame and jumping between them. Like recursion is very much avoided pretty often. And then if the way that the WASM multi-memory proposal works is, I can't remember if it's operations themselves. Actually, I can check it. If we do, does we have the multi-memory proposal in here? WASM. Let's see, overview. I wonder, where's the opcodes? But given any code so far can only address 1, reserving 1 register for the... Anyway, yeah, to simplify, actually, let's just do multi-memory proposal opcodes. Can I do the opcodes? Anyway, I remember from reading this all before that the way that the WASM memory proposal works is usually every single memory operation is implicitly relative to this first store. But if you have, say, multiple stores that you want to link to a program, now you need them to not all be implicitly linked to that first store. Now you have what they essentially did is added another argument to any memory load operation, to where now memory load operations have to say which store that they're loading from. So it might be part of like the WAT format of like which store they're accessing, which means at runtime you can't actually choose, you can't like have a pointer that could be pointing to this store or this store. I may be misunderstanding that. Like, it may be possible to have a wide pointer that can also store which memory you're accessing, want to access with that pointer. But yeah, I don't know. I just remember that being one of like the extreme like drawbacks of the multi-memory system that made it like not viable for what I wanted to do. But with my system, so we only have a 65 kilobyte sized pages, but if we just allow the runtime through like API calls with BraneScript, like essentially syscalls within the BraneScript system, to rebind these memories or like bind them at runtime. So in WASM, when you instantiate a module, you must also link all the memories it's expecting. With BraneScript, I'm going to make it so you can runtime link and like swap around registers of like which memory is currently accessible by the script. So now BraneScript pointers will just be a 32-bit integer where the first 16 bits are which store to access, and the other 16 bits are your index within that store. So if you have a structure, like an iterator structure, it would be able to handle behind the scenes even like switching between different stores. So you could have arrays larger than 65 bytes or 65k bytes. You would just have to page through memory to do that, which I don't think is too big of a drawback because I'll abstract over it in most cases. And then if you're like iterating over like huge mesh data, that's where potentially a large load operator would come into play, because I could make there be a second type of pointer, which would be just a 32-bit. It might be a wide pointer that would be like U32, and then another, that's a 6. So two 32-bit ints. And this could be our large data pointer. And that would have a different operator to load with, and that operator would be runtimes bounds checked. So if I wanted to just do a not paged section of memory and expose that to BraneScript, like say a very large mesh, I could optionally do runtimes bounds checking for that, like, I guess, memory that I want to be more capable at accessing. Because with the 65k byte pages, I don't have to do any checking. Like, you physically can't escape accessing the memory that I've given you access to. Mathematically impossible. With this, it would be mathematically possible, because I'm not allocating 4 bytes of memory ever, like, anywhere. That's insane. So these types of pointers would be runtimes bounds checked and required different operators. Whereas these would always be perfectly secure, and they would also be like very fast. because you, instead of doing like an if statement and doing branching, instead it's like one table lookup, and you're done. Potentially, actually no, I could just zero out all the tables, and then this, I might make it so this is a byte at the beginning here, so it's only like yeah, anyway. Yeah. There's other things I can do to potentially do weirdly sized sections of memory, which is, instead of doing like OR operations on here, I could literally do like a bit and operation to I guess segment this by powers of 2. So I could technically do double the size of 64-bit ints by just adding in that XOR operation, or not XOR, but just OR, not OR. It would be a bit and operation. And I think I wouldn't want to do there to be 65 possible registers. I would probably have it start out as only being, let's call it 108 possible registers. And then do the XOR operation on this argument here. Yeah. So this would require a little bit more. It wouldn't require any branching, is what I'm saying. And like, if a malicious user tries to like manipulate the bits of pointers to try to access host memory that the script hasn't explicitly been given access to, they just straight up can't. The program will just default to accessing some other memory store. Because if I just if I just allocate an array, like a lookup table, to these, like pointers to the start of these memories, and this is a lookup table that has, let's call it 128 sections in this pointer, then if I just always XOR this, so it can only ever be, not XOR, an AND operation, bit AND operation, like a bit mask essentially. Bit mask this first value, so it can only be pointing to one of these, and these are all zeroed out if they're, actually I wouldn't zero them out, because I don't want to be able to call this an exception. I zero all these out to the first store memory, and then when you bind, it replaces the store memory pointer with the pointer to that memory. And then when we unbind that memory, it resets the pointer to then again point at the store memory. So then this lookup table will always return either an explicitly bound memory or the default like store memory of the script, like, and no in between. So like, if I have global variables, they go here. And then maybe we have another store that is like, this is the current running pipeline context, which is in index 1. So index 0 is global variables, index 1 is the store data, so like input variables and whatnot. In fact, input variable, no, I do want the input variables to be a per pipeline thing and not accessible. I don't want pipelines to be able to access the values of other instances from a security standpoint, so they would have their own allocated store here. Yeah, and then if an attacker explicitly tries to tamper with this value to access a store that currently isn't bound, that just gives them a pointer to this memory here, which they can't do anything with. It's global variables. And also doesn't cause an exception. So they're just like, oh, why is my memory weird? But it's not any weird memory that I want. It's literally just store values. It's just structurally impossible to access memory that we don't want people accessing. Yeah. All right. So that long, very long explanation of why I might eventually add extra load operations here. And all of those are just binary operators. So now we get to... I don't need to write a serializer for this yet, because we just need to... We can throw what we generate here directly over to the compiler. The serializer isn't needed until like 2 weeks from now, probably, when I actually want to start putting this in the engine. Quick once over, does this have every single operator that I need it to have? Deleting the cast operators, because those can be implicitly done by the move operator. To change this to IR node, which is literally just a shared pointer. Okay. And... are we done? Is this all I need to write? This might be all I need to write. I might just need to jump into implementing this, implementing a compiler, and then go from there. So we're going to make that a lot smaller because we don't need it. And then we are going to add compiler back to the build targets that we compile. And let me parse out what I was trying to do here before giving up. So we have a compile result, which should give us a... Actually, I'll just use my result type here. So our compiler will give us a compile result, which will just be a result with that as the error type. And then on success, we get a standard vector of modules. Thing is, we might still want to have compiler messages if... Yeah, we do want messages. So instead of that, we will have IR module. Apparently I don't have this under the Brane script namespace, which we will fix now. Don't need a symbol lookup table. I don't need these. Actually, no, I do need these. So these are like if I was compiling this to actually load into the runtime, which I'm not. This compiler is technically writing out assembly language, which would then go to, not assembly language, but like Brane script intermediate representation, which then would go to a sort of assembler in the actual runtime. What is this identifiable? Identifiers? Okay. Did my music run out? Okay, the distant music I'm hearing is from in-game in the world. Okay, I was so confused. Like, I slightly hear music, but I don't hear music. I'm gonna change all of these to IR node. And pipeline stages are actually going to be functions. Did I actually do that? I did. So I have this pipeline stage, which is going to be a vector that is not optional of functions. I guess now I have to decide how I represent functions in Brane script, because function pointers, I know how function pointers work in WebAssembly, and I'm not sure if it's how I want function pointers to work in Brane script. I might have to pull the same thing that I'm doing with the yeah. I might have to pull the same trick that I'm doing with memory, but I might have to pull that explicitly with function tables as well. Because the way that function pointers work in WebAssembly is that all of your functions are essentially indexed. So when you call a function, it's by a pointer. If you pass in 2, it is the second function defined in the module. Because all of WASM is like a function table. And then imported functions are also added to that table. So if you have an imported function and you like pass function of pointers around in your program, they're just indexes. So I need to decide how I want to do function pointers. If I want to do function pointers, which I want to do a lot of functional programming, like passing in lambdas into other operations. But the problem with that, potentially, is I guess I have to do pipeline references as well, because already in my test, no, not in my test grammar, but like let's not worry about function pointers for now. I'll figure out function pointers when I get to a situation that needs function pointers. How about that? For now, we need to define template stages. Which, I guess the reason I was waffling on that is I was like, do we just say that each one of these stages aligns with this function in our vector of functions? And I think, yeah. It's hard to keep track of, but it's efficient and it will work, because the idea behind intermediate representation is this is the final output. There's no more optimization that happens after you do IR, unless it's reloaded into a different format that is optimizable, such as LLVM IR, which is what we actually run the optimizer on. And we might eventually write an LLVM backend to emit this intermediate representation. However, that is not something that, I'm planning to do anytime soon. So, yeah. Wait, I wonder if LLVM backends is literally just LLVM IR to... No, because there's, optimizations you do with, what assembler... Yeah, backends are to, go straight to assembly, so they probably have some utilities for what is the most optimal command in this situation, yada yada. The optimizations like that. So... thoughts on neural network powered processors? You mean processors built specifically for neural networks? Or doing processing with neural networks? Because if it's the latter, hell nah. If it's the former, now that's a fun discussion. The idea of making different architectures specifically for one paradigm of computing is very interesting to me, and I think that's cool. Doing computing with, LLMs? Dude, why are you using... That's so inefficient. That's like using an interpreter for code. Why would you do it? I probably should start documenting. Every day, one step closer to IRL Terminator update, indeed. I'm gonna delete these comments and start... Well, look, I have a thing. That is well documented. Let's just use this. Where with binary serialization, I can convert this to the less human-readable version that's more efficient. But if we're serializing this to the human-readable version, I can keep it as the inefficient string and it will look good. Amazing. Thank you, past me. Thank you, past me. Screw you, future me. Alright, so modules... Yeah, I think it makes sense to have a set of modules. Why use shared pointers over unique pointers or no pointers at all? In the case of variants like this, it makes the size of the variant a lot smaller and easier to swap between. It's mostly because I'm using variants. And a couple other things like casting and whatnot. And then for shared pointer, that's because I want to pass references around and actually be memory safe, because I am a little bit rust-brained. So it's like, oh, strong reference, weak reference, atomic reference counted, blah, blah, blah. But, yeah, the other reason it's shared pointers is because these identifiables also, like, an IR module referenced here could also be identified by these identifiers, for instance. That is, like, they could be in two places at once. Or technically, I guess I could do weak references here. That'd probably be a better idea. That way identifiers, I can just do a quick lookup like, oh, is this identifier, yeah. Is this identifier still valid and still, like, if I do a thing like reloads, because one of the things I might do is like hot reloading. Like, that's something that I very much want to look into supporting, just because it makes everything so much easier. Initially, like, hot reloading is like, oh, let's run the entire pipeline every single time, and then it's like, okay, let's see how much caching we can do in the pipeline every single time. So I'd only be worried about doing weak versus shared and identifiable for a hot reloading scenario where I'm changing this on the fly when these sources are changing. In which case I might need to make a graph of which sources affect which modules, because if you have one module defined in multiple sources, I combine it into a single module on the back end, because the way that I'm doing, I'm planning for stuff to be implemented is modules are your compile targets, essentially. Like, each module is a different compile target. In hot reloading, does the underlying memory change? The sources, the code, if you have variables in memory, that doesn't change. So the program would retain the same state, theoretically. If the layout of your data, like, structures change, then it becomes a lot harder to do hot runtime reloading. I think the way that Unity does it is they just wipe all static variables, and then, like, for public variables on stuff, they serialize those and then deserialize them after the reload is done, so that avoids any, like, memory layout shifts. Because you just nuke the stuff that you can't serialize and then serialize the stuff that you can serialize, and everything else gets wiped. And that is a problem that I'm not quite sure how I want to solve yet. The serialize deserialize route does seem like a good one. What would be interesting to me is the possibility of having, like, writing a reload script where it's like, hey, we've detected that on this reload, these structures will change. Write a quick script to convert the old struct to the new struct, however you want to. And that would not be for, like, every single reload you do in the editor. This is, like, if you want to push an update out to an active player base as they're playing, because that's something you theoretically could do for, like, live events and stuff, then it makes sense to be like, okay, instead of, like, just nuking all the variables and introducing a ton of bugs in a runtime environment, where, like, people are actively using your code, instead you can be like, it secretly reloads in the background, and the data is, like, upgraded. That is something that I want to experiment with. So let's see what I was trying to do here. I probably just want to nuke everything for now. Except for record message, that makes sense. Right now we pass in a vector of sources. I can work with that. So we're going to assume that before the compiler, there was some form of expander stage that filled in all of our that filled in all the variables that like had implicit types and whatnot. Like that's all filled in. This parsed document contains a document context with a fully expanded result. Actually, I guess the expander could be a second stage of the get document context. Anyway, when you call the get document context, you get something that has a full document context. With a parser result. And this document will be in a valid state because I don't store invalid state, I think? I'm not sure. I might need to have like a parse successfully flag or something in here. Or we can just let messages like just stack up forever. That we can also do that too. Then this needs to be namespaced. Have you written a compiler before? I have. Like, I want to say this is my fourth-ish attempt at writing a language. And last time I got, like, pretty far. Like, I had generic functions and a lot of very fun stuff. And the problem is, like, my type system didn't support nested types very well, because I thought, like, oh, I can just make, like... It didn't support nested references very well. My type system was way too simple for that. So... we are starting again, and we're starting again because I had an interesting idea about how to handle asynchronous code, which we're trying to make work. And also it was a good time for me to like rewrite the entire compiler pipeline as well, with what I've learned of like over the last several years. But yeah. And I mean, I guess we aren't technically writing like a full compiler since we're just relying on LLVM for the back end. So we don't have to like write any optimization, which is amazing because optimization is the hard part. Yeah, LLVM, low-level virtual machine. So if you ever have compiled C++ code with Clang, that's from the LLVM project, which is what Rust is built on top of. It's what the C++ side of Zig is built off of. It's what a lot of I think Odin also uses LLVM. Basically, almost every modern language uses LLVM as a backend. And it's what I'm doing too. So I'm not using MLIR. That's one of the JIT runtimes, right? Unless this is... I don't think this is what I'm doing, no. What I'm doing is a lot closer to this. This is the tutorial I used. So we're just like directly calling the LLVM C++ API for like RISC, basically doing like RISC instructions, coding and assembly, but with functions, but slightly higher level than assembly, because you don't have to deal with like comparisons and the flags that comparisons set and all that fun stuff. Oh look, I start out by just clearing everything. That would do it. What is the global module? Oh, right. This is like the module that I would put all code in that wasn't in a module, but we aren't doing that. Basically Java's native interface, but bad? What is Java's native interface? Can you just write, like, emit Java intermediate representation? Allows Java code to interact with native code written on other languages like C and C++. With assembly, it enables Java applications to do it. Okay, so it's more like the ability to link to C++ and C. Okay, do I want to do an index symbols pass? I need to do an index symbols pass. Oh, that wasn't a semicolon. Then again, we don't really need, technically, to index symbols, since... Hmm. It all depends on how I want to do symbol lookup. Because we already have symbols indexed in parsed documents. How do I want to do symbol lookups? Oh, I was originally doing this with TypeScript nodes. Wow. Not TypeScript. Tree-sitter nodes. Sorry, I see TS and I think TypeScript, but it's tree-sitter because TypeScript is not touching this project aside from tree-sitter that has a JavaScript grammar file. Yeah, the main thing that I'm thinking about right now is symbol resolution. I think that's the name for it. Like, when you call a function and you just call it by its short name instead of saying, this is the function from the module whatever that is an implementation of this trait on this structure. Instead of spelling out its full name, you like, yeah. I think I am overthinking it, though. I don't need any of these parse functions, though. Basically, what we need to do here is go over the entire parsed document. And for each one of the structures in the parsed document, generate the associated intermediate representation, which is a very much slimmed down version of that. But also slightly expanded. Because it stores the actual operations we want to do. Like the intention. So I want to let... So I want name resolution to be handled by the document context, because the document context will also be used by the language server, like for debug info. That will also be used over there, and I don't want to have to run the full compiler every single time. So we don't need to index symbols. At some point we'll need to have a validation stage. Not at the moment. Who texted me? Let's see this. Ah, I got a response on how much startup booths cost at AWE. I guess that it would be about 3K, and the lowest is 3K. Yeah, this is about the range of prices that I thought it would be. Now to see who was actually texting me. The toll roads, notice of toll evasion. You have an unpaid toll bill on your account. Sent from a Hotmail email address. So, not real. No, guys, actually, I am avoiding tolls. I'm a speed racer that doesn't pay for toll roads. So I'm going to do a pattern that I enjoy doing, which is creating a new compiler internal in the C class. And instead of all of these being in there, I put them in here. And now the compiler class is a thin wrapper for calling this class, in which case I don't have to put a ton of like parser definitions into the header file anymore. And those I just delete. Then this we would just do compiler internal. And then CI would have a and then we just copy all of this, just all of it, into here. And then in here, we just do return ci dot compile. And I can make this a little bit more like put together. But then we don't have to do any of this stuff anymore. Instead, just we still need the compile function. I can put this into here. Message, and then results. Now actually makes sense as a member variable because this only lasts for the length of one singular compile. So instead of like storing a compile result between compilations, I'll have to respond to that later. Hotmail does so still exist? Apparently. So what I need to do is I need to do one pass to collect the module sources for every module. We don't need to clear these because we're a fresh structure. And then we're going to say that... Oh, I deleted the thing. We already had this, but for source in sources, place source this needs to be in square brackets, source dot Hmm. I don't actually care about the parsed documents too much. What I need is to extract out of the parsed documents the modules in the parsed documents. So I don't think I actually need to store sources. But I do need to do Here, 1 second, I'm going to respond to this. So I want to say, for this module ID, we have these modules sources. So that would be a vector of module contexts. So I'd pass in a parsed document, and we'd also pass in a reference to this massive data structure. And then we would just say I also need a different version of this that's for... Actually, let's do document context. This will be module context. And actually, we can just do only this function. And the first thing we'll do is add this module to the mods. Insert module. And I want the long ID for this, which will include parent modules. I'm uncertain on if I want to do parent modules or not. But because like to load the like full module, you always have to load all of the child modules. But I guess if a script relied on only a child of another module, it could load the child only and not the entire parent module. So if I had like a scoped dependency of like, here's the Brane script standard library dash structures, or not structures, slash collections slash lists, and I only wanted the lists module linked, then I could link only the list module. Or only the collections. The entire thing of collections makes more sense. Yeah, that makes more sense. In that context, so we get the long ID for this, and then we just do mod. Their unordered map, bring to net. So this does return a string. Oh, it's because I have a vector. Okay. So I actually, because this operator, I believe, automatically creates one if there isn't one. We could just do this. And this operator I'm just gonna check myself before I wreck myself here. Inserts value type if the key does not exist. That's what I was looking for. So after we've placed that, we'll say for child module in mod. Oh, I don't want to move it then. Actually, I can move it. Oh, it's still gonna have that annoying, like, oh, the parameter mod is copied for each invocation. Even if I do the standard moves, it doesn't matter. Oh, come on. I have submodules. Do I not? Did I remove submodules? I did. Okay. I think I still might let people define modules manually to like look like they're scoped, but yeah, that makes stuff easier. Because now I can just do 4. Oh, it's a node map. Okay. I guess we don't necessarily need to do this anymore. You can just say compile module. And here, actually, when we do the job of going through one by one and command by command and figuring out how to throw everything together. Alright. It is like 6:30 for me, so it's about time for me to go grab dinner. So I'm gonna go do that, and then probably keep working on this off stream after the fact. We'll post an update in the Discord if I do, like, end up being able to print intermediate representation before the end of the day, which would be really cool, and it's kind of what I'm going for. Like, everything's there for me to be able to do it. I've, like, solved all these problems before, so hopefully, theoretically, it won't be hard this time, because I've implemented this sort of thing before so many times, and the hard part was just deciding, like, the representation that I wanted to use. So, I'm gonna go eat dinner, and then get back to work. But for those of you who stuck around, thank you, and I will see you next time.